When we're thinking about molecules and compounds and what actually makes a molecule or a compound, it's all about the atoms being held together. The way they're being held together is through a bond, and we talked about two different types of bonds, ionic bonds and covalent bonds. Ionic bonds are basically electrons being transferred from the one atom to another. Usually it's a metal with a nonmetal. And then we also have the covalent bond, which is a sharing of electrons. It's all about the electrons, and that is the basis of all of chemistry. So those atoms being held together, those bonds, are what we call intramolecular forces because they are within the molecule themselves. However, if we think about the molecules, like let's say for example in a solid or liquid, the molecules are held closely together. And so just like the atoms are held close together in a bond, in a solid or liquid, the molecules are also held together, close together. So what are the forces that are holding molecules close together to make them into a solid or a liquid? I mean, if those forces weren't present, everything would be a gas. Those molecules will be as far apart from each other as possible. So there's got to be some attractiveness that actually holds these molecules together. Well, we group that attractiveness that the molecules have as intermolecular forces. Intermolecular forces are forces that the molecules have with each other. So there are two major types of forces in chemistry. We have intramolecular forces and intermolecular forces. Intramolecular are within the molecule. Intermolecular are basically between the molecules themselves. Now there are three types of intermolecular forces. The forces that actually keep the molecules close together. The weakest of all the forces, so I'm going to go in order from the weakest to the strongest. So the weakest of the forces, of the three forces, are what we call dispersion forces. Dispersion forces are basically the fact that all molecules have electrons. I mean, those electrons are in place because of the atoms, and those atoms have those bonds that are the molecule is being held together within the molecule with those bonds, and so there's electrons that are kind of all around that molecule, and those electrons are constantly moving. Especially if we think about a covalent bond, there's that sharing of electrons between the different atoms. And so sometimes those electrons get shared by one atom versus another. And so there is kind of a shift in the charge that happens in a molecule. And it happens kind of instantaneously and all throughout, where one part of the molecule kind of has a subtle negative charge when it has a little bit more electrons on one end of the molecule. And then on the other side, it might be a little bit positive. Because you got to think about it, these electrons are always moving around, and so there's going to be times when there's one part of the molecule that's going to have a little bit more electrons or electrical charge than the other side, and so there's going to be kind of a slightly negative part on one part of the molecule and a slightly positive part on the other. The technical term for this is what we call polarizability. So the fact that atoms and molecules, where those electrons are constantly moving around and they can kind of congregate on one part of the atom or molecule and make that part a little bit negative, or on the other side a little bit positive, is the polarizability. And so because then these molecules or atoms have a positive and a negative, or I should say a slight positive and negative part to it, it can then be attracted to other molecules that have also a slightly positive and a negative. So the positive part of one molecule will be attracted to the negative part of another molecule, and that's kind of going to hold the molecules together. Now these are what we call dispersion forces, and the dispersion, because it's dispersed throughout, they are the weakest of the three forces. The next strongest force is what we call a dipole-dipole force, or a dipole-dipole interaction. Now, if we think about the molecule itself, some molecules have a kind of a negative part to it, and that is especially true when we're talking about polar molecules. A polar molecule has a dipole, and so that means it has a negative end and a positive end. That negative and positive end basically comes about because there's a lot more electrons. So let's think of, for example, something that has oxygen bonded to it. Those oxygen atoms are going to have lots of electrons around it. And then if we have something that is not as much electronegative, like a metal, for example, that metal is going to be a little bit positive. And so we're going to have a dipole there. We're going to have a positive part and a negative part. And that's always going to be present in that molecule. Since we always have a positive and negative, there's going to be the attraction with those other molecules that is also going to keep all the molecules really close together. And this is one reason why ionic compounds, or I should say ionic bonds, are the strongest, or the ionic materials have very high melting points and boiling points. It's because those elements are basically ions, which are very strongly positive or negative depending on if it's a cation or an anion, and it's going to have a positive and negative end. And so the positive and negative end is going to get attracted to the positive or negative end of the other side, and it's going to stick together. And that's what basically a solid is. A solid, let's say sodium chloride, is a positive sodium and a negative chlorine stuck together. And it requires a whole lot of energy to separate those out. And so that's a very extreme case of a dipole-dipole interaction. This dipole-dipole interaction is not the strongest interaction that's present for molecules. Ion-ion dipole interactions are the strongest. That is like the absolute strongest. But there's a kind of a in-between interaction that happens between just regular dipole-dipole interactions and the extreme ion-ion interaction. And that is what we call hydrogen bonding. So hydrogen bonding, you might say, oh, well, if anything, hydrogen bonding is going to exist wherever there's a hydrogen atom. And that is sort of true. So let's first talk about what hydrogen bonding is. Hydrogen bonding is where we have a hydrogen atom bonded to a very high electronegative element. In particular, is either fluorine, oxygen, or nitrogen. So when we have hydrogen bonded to one of those three atoms, we're going to see hydrogen bonding present. Now, what is hydrogen bonding? So let's think about what happens in that molecule. If we have an oxygen and a hydrogen, that oxygen really wants that electron from that hydrogen. Remember, hydrogen just has one electron. And so hydrogen consists of one electron and one proton. And so when that hydrogen is bonded to that oxygen is pretty much going to take that electron. And so what is left at that hydrogen? Basically just a proton. It is what we could say maybe like a naked proton, a naked hydrogen. There's nothing there but the proton. That's all that's there for the hydrogen. And so we have a pure positive charge now where that hydrogen atom. It is a proton that's basically bonded to a fluorine atom, a nitrogen atom, or an oxygen atom. So because we have this just pure positive proton now that's hanging on this molecule, that positive is going to be really attracted to the negative end of that same molecule. Because remember, there's a positive part, there's that corresponding negative part. And so we go to the molecule right next to it, that negative part of that molecule is now going to get stuck to that positive part. And so that is what hydrogen bonding is. Hydrogen bonding happens between two different molecules that are kind of stuck together, where where the molecules themselves have a hydrogen atom bonded to a fluorine, nitrogen, or an oxygen atom. And so that hydrogen, when it's bonded to one of those three elements, is basically a pure proton that then is going to be attracted to the negative part. So the oxygen, the nitrogen, and the fluorine is going to be the negative part. And so that positive is going to be attracted to the negative part, the fluorine, oxygen, or nitrogen of neighboring molecules. And so hydrogen bonding is much stronger. It's a more extreme case of dipole-dipole interaction. And so, again, the three major types of intermolecular forces that are present in molecules are dispersion forces. Next is the dipole-dipole interaction, and then finally hydrogen bonding, which is the strongest. Now, I did mention ion-ion attraction, and that is really only between ionic compounds. And so what we're talking about here are really covalently bonded compounds. So those are the three intermolecular forces. And those intermolecular forces will help us describe and explain the properties that we see in many different compounds.